Part 7, an introduction to simple linear inequalities. You will find this on page 119 in the Namibian Mathematics Grade 8 textbook, y equals mx plus c to success. Introduction to inequalities. An inequality tells us about the relative size of two values. Mathematics is not always about equal. Sometimes we only know that one value is bigger or smaller than the other. For example, Inka has more sweets than Mark. We can write that down like this. Inka more, can you see the mouth is looking towards Inka, has more sweets than Mark. We learn how to represent numbers on a number line in chapter 2. On the number line, numbers on the left are smaller than numbers on the right. So these numbers are smaller than these numbers. They are easy to remember. The small sharp end always point to the smaller number like this. So that small sharp end to the smaller, and the big mouth, you can make it a mouth, is pointing towards the bigger number. The two most common inequalities are, if you read it from this side, bigger, smaller. So greater than, so saying 2 is greater than -4, or smaller, less than, -4 is less than, smaller than -2. Because -4 is there and -2 is there, so it's more to the left, that's why -4 is smaller. Okay, the two other inequalities are greater than or equal to, y is greater than or equal to 1, less than or equal to, less than, x is less or equal to 3. Let's look at two examples. You must be 13 or older to go to the function, meaning your age must be greater than or equal to 13, which is written your age must be bigger or greater and equal to 13 before you can go to the function. To eat a kiddie's meal at the restaurant, you must be 12 years or younger, meaning your age must be less than or equal to 12, which is written as your age must be less or equal, can put it a little bit up, than 12. Okay, I'm going to go through this investigation so that it helps you to solve simple linear inequalities. In this investigation, we will explore some properties of inequalities. Complete the table by using the inequality 20 is bigger than 8 or greater than 8 and doing the following operations: multiplication and division. Okay, multiplication by a positive number, multiply 4 on both sides of the inequality. So I times 4 and I times 4 and I get 80 is bigger than 32. That is true. Is the inequality sign reversed? No, not necessary. Okay, division by a positive number. Divide 4 on both sides of the inequality. So let's just do that one. So basically, I'm going to just say 20 divide 4, and I'm going to keep it and say 8 divide 4, and then I'm going to get 5 is bigger than 2. So basically, I'm getting 5 is bigger than 2. Is that true or is it false? This is true. Did I reverse the inequality sign? It's not necessary because it's true. It's only necessary if it's false. Okay. Now, if I look at this one, multiplication by a negative number. So on both sides of the inequality. So if I multiply a negative, I multiply and I multiply. I get -80 is greater than -32. That is false. But if I reverse the inequality sign, so I change it from that bigger to a smaller, then I made this statement true. Now, let's do the same with this one. So we're going to say just 20 divide -4. And we keep the sign and we say 8 divide -4. Let's just look at the answers. We're going to get -5 is greater than -2. And this is definitely also, let's just rewrite it, -5. This is definitely false. So basically, I have to reverse the inequality sign and do it like this. to make the statement. Now the statement will be true. So from this investigation, we can conclude that we can multiply or divide both sides of the inequality by a positive number without having to reverse the inequality sign. So if I multiply or divide by a positive, it was all right. However, if we multiply or divide both sides of the inequality by a negative number, we have to reverse the inequality sign to make the statement true. And please remember it when you are solving simple linear inequalities.